Hello class, so before we proceed with the next types or classifications of order 1 differential equations, we will first discuss IVPs or initial value problems. As we have discussed last time, when we say we are finding the solution to a differential equation, ang ginagawa natin class is we do integration para matanggal natin yung mga differentials. Kasi hindi natin magagamit yung differential equation, hindi natin magagamit yung isang equation na may mga differential. Kasi hindi mo naman pwedeng makuha lang basta-basta yung value ng dy saka ng dx. Kasi diba by description, hindi naman siya natin basta-basta mapoprovide. So kaya nag-integrate tayo. Now, kung ganun pala yung case, sir, kala ko po papunta tayo sa pagsosolve ng mga problems na real world problems or physical phenomenon. Kaya tinatanggal natin yung dy at dx para magamit natin siya. Bakit ganun, sir? Nung tinanggal natin siya, nagkaroon naman tayo ng arbitrary constant. Yung arbitrary constant, hindi rin natin alam yung value niya. So, kapag ganun class yung case, ang kailangan natin ay initial conditions. Because if we have initial conditions, pwede nating ma-solve yung value nung arbitrary constant natin. So, IVP's class. So, in the field of differential equations, an initial value problem is an ordinary DE together with a specified value. Na nabanggit ko nga kanina, ang tawag natin ay initial condition. And yung initial condition natin, that is the value of the variables in the function at a given point in the domain of the solution. So, part siya. Kumbaga, it's a point kung may curve or may line or may value or may set of values ka for that function, isang point doon, bibigyan ka. Yun yung initial condition natin. So, in initial value problems, the arbitrary constant can be determined by substituting the initial values for the variables. Halimbawa, class, meron kang differential equation na x plus y is equal to c. This is your general solution. Kasi meron tayong arbitrary constant. Now, ang sabi dito, pag binigyan ka daw ng initial condition, which is a point doon sa domain ng solution, in short, it's a value of x and y na part ng equation na to, then obviously class, pwede mong magamit yon to find for the value of c. Kung meron kang isang point na alam mo yung x at alam mo yung y, pag sinubstitute mo yun dito, makukuha mo yung value ng c natin. So, yun yung gusto nating mangyari kapag magsosolve tayo ng initial value problems. So, since makukuha natin yung value ng c, hindi na natin siya tinatawag as general solution. Ang tawag na natin sa kanya class ay particular solutions. So, a particular solution is derived from the general solution by substituting the value of your arbitrary constant na makukuha mo by using the initial conditions. So, para mas madali, apply natin sa problem. We have 2xy, y prime is equal to 1 plus y squared. Ang initial condition daw natin, ang y of 2 natin is equal to 3. So, ito review lang ng function. No? Alam naman natin ibig sabihin yan. Di ba kapag y of 2 or function halimbawa, we have a function y of x. Kapag daw ang value ng x mo ay 2, ang y mo is 3. So, therefore, class, if x is equal to 2, and then ang y mo daw is equal to 3. So, yun yung ibig sabihin niya. Ito ngayon, class, yung condition na gagamitin natin kapag nakuha natin yung general solution. Isa-substitute natin to, makukuha natin yung c. So, yun yung target natin na mangyari dito. So, una natin gawing class is express muna natin yung y prime as dy over dx para mapag-separate natin yung mga differentials nila. Multiply natin sa dx yung whole equation. And then, divide natin by 1 plus y squared tsaka x. So, kapag ganun class, ang lalabas is 2y dy over 1 plus y squared is equal to dx over x. So, this is already a integration ready na equation because it's in a form na lahat ng x nakamultiply lang sa dx and lahat ng y nakamultiply lang sa dy. So, if we take the derivative, this will be this will be integral of, not derivative pala, integral. We have 2y dy over 1 plus y squared is equal to the integral of dx over x. Okay, so integral, ang integral nito class is ln 1 plus y squared. So, konting review lang, pero ito dapat reviewin nyo na ng sarili nyo. Diba, ang ln u ay equal yan sa integral of u, ayan, du over u. So in this case, ang u natin is 1 plus y squared. Ang du niya is 2y. So ibig sabihin, pasok siya dito sa natin na to. Sa kumbaga integral rule na yan. So therefore, we will have ln 1 plus y squared. And then equal to, actually same to, ln lang din to, du over u. So we have ln x plus c. Pero ang gawin natin, c sub 1. Now, dapat by this time, ma-familiarize na tayo tuwing kailan ba natin pwedeng manipulahin yung arbitrary constant natin. So, as we have discussed last time, pwede nating baguhin to as long as ang kakalabasan niya is numerical value. So, napansin natin, yung lahat ng terms natin, except the arbitrary constant, naka-ln. Now, kapag in-ln ko ba ang isang constant, ano yung kakalabasan? Di ba numerical value pa rin? If you, halimbawa, ginawa ko ln ang isang constant na ang value ay numerical, ang kakalabasan nun is still a numerical value. So therefore, class, pwede nating ibahin to, baguhin natin. So if we let c sub 1, gawin nating ln c, so we will arrive an equation na lahat naka-ln. So we have ln 1 plus y squared minus ln x is equal to ln c. So rules of logarithm lang. We have naka-minus, so division yan. ln 1 plus y squared over x is equal to ln c. Now, ang pwede natin gawin class, tanggalin natin yung ln para sumimple yung equation. To do that, we can erase natin, gawin nating power ng e, yung mga terms natin. Diba remember class, ln is logarithm to the base e. So, e, ito yung base mo, so makakancel yan. So, principles lang ng logarithm. So, we will arrive class at, kung mawawala na to, we will have 1 plus y squared over x is equal to c. So, this is class our general solution. Okay, now this time around class, pwede nating mahanap yung value ng c using the initial conditions. That is, at x is equal to 2, ang y daw natin ay equal to 3. So, substituting, napakasimple, we will arrive at c is equal to 5. Now, we can now substitute that to our equation. Let's plug in the arbitrary constant to the general solution, and we will have 1 plus y squared over x is equal to 5. Tanggalin natin yung mga denominator, etc. Actually, ito, pwede na to. Tama na yung sagot na yan. But if we want to simplify, usually, ang ginagawa natin, in-express natin siya sa function nung dependent variable. So, in this case, ang dependent variable natin is y, di ba? So, sinimplify natin siya para it's a function of y it's a function y na ang variable niya ay x. So, by yun nga, doing simple, multiply and then nag-transpose tayo, we'll have y is equal to square root of 5x minus 1. So, this is our answer. So, nakita class, ang ginawa lang natin, pinlog in natin yung general solution. If ang pinag-uusapan natin, halimbawa, equation na to ay kinuha natin sa isang actual na physical phenomena. O, kapag meron ka ng y, pwede mo nang makuha yung x. Or pag meron ka ng x, pwede mo nang makuha yung y. So, ganun yung target natin. Another example, we have dr over dy. Oh, mali to. dt. Yan. So, dr over dt is equal to negative 4rt. So, when t is equal to 0 daw, r is equal to r sub o. So, una na muna natin gawin, syempre, find the general solution muna. So we have dr over dt is equal to negative 4RT. So separate natin yung variables. We will arrive at dr over r is equal to negative 4t dt. Then take the integral. So we will have ln r is equal to negative 2t squared plus c. Substitute na natin yung initial conditions. So at t is equal to 0, r is equal to r sub o. So we have yung r, palitan natin ng r sub o, lahat ng t, palitan natin ng 0. So we have ln r sub o is equal to negative 2 times 0 squared plus c. So mawawala to, ang matitira na lang class is, ang c natin is equal to ln r sub o. Next is i-plug na natin siya dun sa equation natin. Palitan natin yung c. We will have ln r is equal to negative 2t squared plus ln ro. Pagsamahin natin yung ln sa isang side. So, nag-subtract sila. So, pwede natin yung gawin na ln is equal to r over r sub o is equal to e raised to 2t squared. Now, ang dependent variable natin is r, di ba? So, maganda na matanggal din natin yung ln. So, gawin natin na power ng e, yung mga terms natin. So, matitira class is maka-cancel to. We will have r over r sub o is equal to e raised to negative 2t squared. Multiply natin yung ro dito para mawala yung denominator and r na lang yung nasa isang side. We will have r is equal to r sub o e raised to negative 2t squared. So, ano yung ibig sabihin nito, class? If you have the value of r sub o, pwede mo nang masolve yung value ng r and vice versa. Also, value ng time as well. So, nabawasan na class yung mga mga unknowns natin doon sa equation. Yun class. So, that is our discussion for initial value problems. Now, take note class, ang initial value problems, hindi lang siya applicable sa mga variable separable differential equations. Ngayon lang natin diniscuss because in the discussions in the future, may encounter pa natin siya lagi. Lahat ng differential equations na i-discuss natin in this chapter, in fact, ay may mga initial value problems din. So, ano lang yung magiging difference? Siyempre, kapag iba na yung differential equation, iba na yung paraan ng pagsasolve. Pero the rest, parehas lang. Ang aim mo, ma-eliminate muna yung mga differential. Tapos, makuha mo yung general solution. Ma-eliminate mo yung mga differentials and in the process, makuha yung general solution. And then next is, kung may initial values ka, gamitin mo yung initial values na yon to get the value of your arbitrary constant and in that process, makuha mo yung particular solution. And yun na yun. Yun na yung ginagamit natin sa mga real-world na problems. So, that is our discussion for IVPs. So, expect nyo na ma-encounter nyo pa to in the future na mga discussions natin.